Hello and good afternoon, CSI258 Section 847 students for the second 8-week term in the 2015 spring semester at Anne Arundel Community College. This afternoon's Packet Tracer tutorial is going to be on Packet Tracer Activity 5.2.2.5, where we're going to be configuring Dynamic NAT. And this is going to build on the activity that we had previously done, 5.2.1.4, where we configured Static NAT, where Static NAT provided us with a one-to-one mapping of inside local address to inside global address. And so the inside local address, again, remembering that's going to be our RFC 1918 private address. And I'm actually going to draw a line down the middle of R2 here. So this side is going to be our RFC 1918 addresses over here. These are the inside local addresses. And these are going to be the public addresses, aka our inside global addresses. And there are a couple significant differences when configuring Dynamic NAT as opposed to Static NAT. Again, remember we said that Static NAT, go ahead and put that up here, so static was equal to a one-to-one relationship, so one inside local to one inside global. However, Dynamic NAT is one to many. So we're going to create a pool of addresses. Another significant difference between this activity and 5.2.1.4, very subtle difference but very significant, is the use case. So previously we had a server on the inside of the network which we needed to come from the internet to access. And so that requires a static NAT translation because we want that IP address, the inside global that we're seeing that maps to that inside local for the server, we want that to be static. We don't want it to change. So if maybe we had a web server here, right? And the inside address was 172.16.10. and we'll say 100, we would want this inside local to map to the same inside global so that people out here on the internet, when they reference the inside global address, router 2 always knows that I have a static mapping to get there. And again, that's one of the major use cases of static NAT, is when you need to make a connection, initiate your connection from outside of the network and come into the network to get to the component you're trying to get to. And so that was a great use case in 5.2.1.4. However, take a look here. What do we have? We've got laptop 1, PC 1, and PC 2. No servers, right? No web servers, no database servers. So when we look at this use case through the lens of which type of NAT are we going to use, there doesn't appear to be a requirement to where I would say, hey, out here on the internet, I need to be able to initiate a connection from the internet into PC2. It doesn't work like that with Dynamic NAT. Static NAT, yes, but Dynamic NAT is basically saying, I've got a bunch of employees back here, workstations, laptops, whatever, and they need to initiate a connection out to the internet, right? So that's different. Instead of, static NAT was we could go from the inside to the outside or initiate the connection from the outside to the inside. Dynamic NAT is saying, I'm going to go from the inside to the outside, but I'm not allowing connections to be initiated from the outside to come inside, right? And so that's our use case here. And again, I've kind of drawn the sort of the demarcation line here as to where we're talking about inside local addresses and then inside global addresses. As you can see here, right, what is this going to be? This is our outside global address, and for the purposes of our curriculum, 99.999% of the time, this outside local address is also going to be the same. So the outside global address and the outside local address will be the same. Okay, So let's go ahead and let's jump into our configuration, because another significant thing we're going to talk about here is how many addresses do we actually get in the pool. You'll see that we've got a /27 that we're dealing with here between us and the internet. So we should have 5 host bits left over, which means we're going to have 30 total usable IPs. However, there's going to be an IP here, right, and an IP on the internet side. So we're going to lose 2 of those 30, leaving us with 28. And we're going to talk about this statement, the pool. When you go to create the pool statement and you put your pool range in and you put the net mask or the prefix size in your pool statement, and how that works out and how many addresses you're really getting out of that range. Okay, so let's go ahead and jump in here. I'm going to do a Control-C real quick. So one of the first things it's asking us to do, it says on router 2, configure one statement for ACL1. So let's go ahead and pull router 2 up. Let's move it out of the way here. And I'm actually going to go ahead and clear the screen, and I'll redraw the demarcation point here in a second. So let's go ahead and make router 2 a little larger. And a couple configuration steps are going to be added here to our Dynamic NAT configuration, right? So in this, oops, and we're going to have to wait here because we got the domain lookup on. All right, so, and we'll talk about that right now. So one of the first things that we need to do is, you'll notice up here, let's draw that demarcation in, right? So this is my inside local, and these will be my inside global addresses that are going to come out of that range in the pool that we create. So we're going to create an ACL that basically says that entire Class B range, right? 172.16.00/16, that entire range is allowed to create an outbound connection. There we go, an outbound connection, and get a mapping of an inside local to an inside global address. So we're going to go from user exec to privilege exec with the enable command, and then we're going to go into global config with the configure terminal command. All right, so the first thing we want to do is we want to create our access list. So I'm just simply going to say, it's always a, well, I shouldn't say always, 99.9% of the time it's going to be a standard access list that is not a named access list. So I'm just going to say access list 1, and what am I doing? I'm going to permit 172.16.0.0, and now I need to put the wildcard mask in here as well. And the wildcard mask, which in this case is the inverse of the net mask for that address range, is going to be 0.0.255.255. And so that is our ACL that we're going to go ahead and associate with a pool of addresses, okay? And so here's where typically the pool command can be a little confusing in terms of, well, which addresses am I actually specifying, and what about the broadcast address when I put the prefix down and I make it smaller than the available range that we have? How many addresses am I actually going to get out of that pool? So we take a look here, and we're going to go ahead and say, it's asking, it says configure R2 with a NAT pool. So we're going to say IP NAT pool, and then the name of the pool, right? Now it doesn't ask us to do anything special here, so I'm just going to say R2 _ pool. And sometimes the exercise will ask you to put a specific name in. Here it's just asking for the pool, right? Now, this is very interesting, the way that this is phrased here, right? And this can become very misleading in some cases. It says a NAT pool that uses all 4 addresses in that address space. Now, when I read this the first time, right, and if you read this, it can give you the impression that what it's asking, what it's saying here is a NAT pool that uses all 4 addresses, and I'll put the little thing in here, for NAT in the 209.165.76.196/30 address space. You could easily imply that that's what it's saying, that it wants you to use .196.197.198 and dot 199, because those would be the 4 addresses that are going to fall into that /30 range. And remember, there are only 2 usable IP addresses in the /30 range. Now, and this is a very key point, so take a look over here. What is the actual size of that subnet? So it's a /27. So what we're saying is we borrowed the first 3 bits, and we're using those first 3 bits to represent the network. And that's why we've got 209.165.76.192. Now the 192 is my network ID, right? That's my network identifier. I cannot use that address as an assignable host address. So I can't put it in my NAT pool. I can't assign it to the interface right here, and this interface is probably .193. We'll take a look at that in a second, and my guess is going to be that that's going to be .194, right? So if my network ID starts at 192, okay, because it's a /27, that means we have 5 host bits, and there's the 5, right? We have 5 host bits available. So how many total usable IPs do we have? Well, 2 to the 5 is 32. I have to subtract, right, -2, the network ID and the broadcast address, so that's going to leave 30 usable IP addresses, okay? So the block size is 32, and by block size I mean the preceding subnet, if it was a /27, would be sitting right at .160, and then this is going to go all the way down to .223 because the next network identifier is going to be 224. So right in the middle of these 2 subnets here, .160 and .224, falls this .192. Now, again, when you read this, it says a pool that uses all 4 addresses in that address space. But is it actually going to use 196 and 199? Because in a /30, remember that there are only 4 total IPs in a /30, of which only 2 can be assigned as usable, right? So you can see here, we've got this question right here that kind of creeps in. What will happen if more than 2 devices attempt to access the internet? Well, let's go ahead, let's do our configuration, and let's see. And that is not what I wanted to do. Let me see if I can pull that. Okay, good. I want to be able to pull that back. All right. So let's go ahead. Let's finish this pool statement out, and we're going to talk a little bit more. And I'm also going to provide a few more examples of the pool configuration and which addresses are being used and which addresses are not going to be used. So IP NAT pool, R2 pool, and now what do I need? I need my starting inside global address, right? And this is the starting address that I would like the pool to start with, okay? And this is where it can become a little confusing. Excuse me, a little confusing. So we're going to go ahead and say 209.165.76.196, right? Because remember, the range that we're in here, right, we're not using the whole /27. We're looking at that .196 right there. So that's going to be my starting inside global IP. Now, what would be my ending, right, the last inside global IP address in this /30? Well, it's going to be 209.165.76.196. Now, just because I've put those as the starting and the 99. Just because I've put those as the starting and the ending IP addresses, does that mean that those 2 addresses that you see there, 196 and 199, are they available to be assigned and used in the pool, right? So my first translation that goes out, is that going to be given 196? Because keep in mind, what follows next is the net mask, right? And so I need to put the network mask in here. Well, for a /30, it's 255.255.252. Now, again, that statement with a NAT pool that uses all 4 addresses in that address space, in that 209.165.76.196/30. It could be read to imply that, oh, 196 and 199, those are going to be assigned out as well. However, let's take a look and let's see what happens, because I've got that net mask on there. When I hit enter, what iOS is doing is iOS is right now, it just did a calculation to check to see, are those addresses, 196 through 199 inclusive, do they first fall within the same subnet boundary, given the fact that this is a /30. So that check succeeds. So that is true. Those addresses do fall in that range for a /30. However, in that /30, what iOS is also saying is that there are only 2 actual assignable host IPs in that range. And so let's see what happens now when we pull router 2 back up here. And let's go ahead and do the rest of the tasks. So task number 1, create the access list that defines which inside local addresses are going to be allowed to connect out through router 2 and receive one of the available inside global addresses that we've made available for mapping inside that network range, right? And so that was the first 2 steps. We created the pool and said starting IP, ending IP. But the starting IP and the ending IP that we used with that net mask /30, this starting IP would be the network identifier, and this ending IP would be the broadcast, if that is the net mask under normal circumstances, right? So let's keep that in mind. So now what do we need to do? Third step, we need to associate the access list with the pool. So that way the pool understands which addresses are going to be allowed to map to the inside globals that have been defined in the pool. So I would say IPNAT inside. Now, remember, with the static in exercise 5214, we add, oops, sorry, I'm going to go one further there. IPNAT inside source. With the static that we did before, we chose static, right? Because we were talking about a one-to-one relationship, an inside local address mapping, so one inside local address mapping to one inside global address, and that address being the same. Those are static, meaning that that mapping, unless you go in and reconfigure it, that mapping is always going to be the same. That the inside local will match every time with the same inside global. And that's in a static configuration. However, here you can see that we are not doing a static configuration. We've created a pool. So this is dynamic in terms of how the inside locals are going to be matched up or mapped to an inside global address. So we're going to put down the list, and what that means is, so basically the way I read it to myself is usually, okay, so my IPNAT statements for the inside sources that are in the following list. So I'm going to be natting for the inside local source addresses that qualify based off of this access list. And that's the access list that we referenced earlier. So I simply put in 1 because that was the number of the standard access list that we used when we said access list 1 permit 172.16.0.0 and then 0.0.255.255. right? And so that's the list that this command is referring to right here, that access list. Okay, so then what comes next? Well, I'm associating the list with the pool. So I'm going to say pool, and just the name that we used for the pool, which in our case was just R2_pool. So now I'm going to put a question mark here because this becomes important as well. So we didn't even see this when we did our static mappings with 5214. We didn't get this far. However, this is the single configuration difference between dynamic NAT and what we call NAT overload, hence the keyword here, overload. So this is the single configuration difference between dynamic NAT and NAT overload, aka PAT, which is if I was doing NAT overload PAT, I would put the overload keyword in here because I have to instruct the router to not do a inside local to inside global mapping. No, the mappings are going to be based off port address translations. Now, dynamic and NAT overload / PAT both can use pools. So that's why this is the differentiator here. So we're going to leave that off right now because we are not doing NAT overload / PAT. We're doing dynamic NAT. So this is going to stay the way it is. We're stopping right here. So that the following packet tracer activity is going to have us get into NAT overload / PAT. And so then we'll see the use of this overload keyword. So for right now, though, dynamic NAT, this is it with respect to the pool and the access list configuration components. So I'm going to hit enter because I've associated my access list with the pool of addresses. Now, just like, so here's a similarity between dynamic NAT and static NAT, is we still need to tell the router which interface is the inside interface and which interface is the outside interface. So let's go ahead. I'm going to say do show IP interface brief. And as you can see, as we suspected, the first assignable IP in that /27 inside global range is .193. And so my guess is going to be that on the internet side, if we're lucky, we would see that it is configured as 194. And I'm going to assume that that's why we're able to ping that address. So the first two addresses in this subnet, this /27 subnet, which are .193 and .194, those have been used. They're spoken for. So they cannot be used. So you'll notice that .195 may be used somewhere, but we started at .196 with our /30. So let's go ahead. I'm going to jump into serial 000, and we know that that is our outside interface. So we're going to type in IPNAT outside. And our inside interface is going to be the serial 001. And we just simply tell the router that this is my inside interface. And so the reason we put these commands on here is so that the router knows when traffic is coming inbound on that serial 000 interface, the outside interface. It's going to take a look at those at those inside global addresses that are the destination addresses that are coming inbound to the outside serial 00 interface, right? It's looking at the inside global addresses because it's going to inspect them to see, do I have a mapping for whatever that inside global address is? Does a mapping exist in my NAT translation table for the inside global? Does it go to a specific inside local? And vice versa, right? On that inside interface, when traffic is coming into the router from the LAN, and let's say that laptop 1 is trying to initiate connectivity out to the server 1 here, right? So laptop 1 initiates its connection. When that traffic enters the serial 001 interface here, the LAN interface on router 2, the router looks at that inside local address for laptop 1 and says, is that address defined in the pool, and does the access list permit that address to even take up one of the inside global addresses so that it can connect out to the internet? If those checks check out, router 2 says, laptop 1, I see your inside local address, and creates a mapping giving it one of the inside global addresses. And then laptop 1 has communications out to the internet, right? So that is the key reason as to why we need to have those commands on there. So we've associated our ACL with the NAT pool, we've configured the NAT interfaces, and now we're going to talk about what happens here. What will happen if more than 2 devices attempt to access the internet? Well, let's find out. So we're going to pull up first laptop 1, and we'll go to the desktop and pull the web browser up, and we're going to type in the IP address 209.165.201.5. And I'm going to go ahead and just hit enter here. And as you can see, it says server 1, welcome to server 1. And so let's quickly on router 2, and I'll go ahead and say end, and we'll save our config. And I'm going to say show IP NAT translations. And in fact, let me go ahead. We're going to take up a little more real estate here. There we go. A little easier to see from this perspective. So what we're taking a look at here is we're using HTTP, right? And the PRO stands for the protocol, okay? And what protocol is HTTP using? It's using TCP, right? So what is my inside global address, right? What is the publicly routable address I'm going to be mapped to here from the laptop? And that address is 209.165.76 dot, and this is very interesting here, right? .197. It does not use my network the subnet ID, which is .196. Okay, do you see that? So it does not use that subnet identifier. So it picks the first usable host IP address. And then you can see we've got additional connection information here. We've got the port number, right? And that's the randomly selected source port. So now we'll take a look. What does the inside local address look like? Well, here is the inside local address. 172.16.11.1. So let's go ahead and confirm that. I'm going to pull the laptop up and let's look at the IP. Whoops. Let me see. The IP configuration. Sure enough, that is the IP address of the laptop. Now, what's a little interesting here is if you think about it, well, then if that's the case, what's the IP here on the router? Typically, the default gateway address is a .1, and they typically, in the packet tracers, they'll use .10 for the IP. However, here they're not, which is okay. There's nothing that says it has to be .10 or .1, so they've changed it up a little bit. But the reason for pulling that up is to demonstrate, and let's get the drawing stuff back up here. There we go. Is to demonstrate that that is the IP address of laptop 1. And again, with the same random source port. Now, here's my outside local and outside global addresses. And like we said, these are going to be the same. Now, are there use cases where that's not going to be the case? Yes. And 2 of those would be the first one is called SNAT, which stands for static NAT address translation, where you can do, I believe, load balancing and things like that. So SNAT is one of those use cases where your outside local and your outside global may be different. And the other use case is if you were merging 2 companies together and you had overlapping address space, where you would have to NAT on both sides, and that would change the outside local, outside global from being the same. So again, for the purposes of the course, right, these addresses are going to be the same, right? But just know that there are use cases where they won't. And this is typically a question that students will ask, and they'll say, well, you know, when is it that you wouldn't have those be the same? And so those are two use cases where they wouldn't be the same. All right, so here is our NAT translation. Now, remember, this is a dynamic NAT translation. I'm going to pull this off of here, and I want to keep the other things, and that's as far back as it's going to let me go. All right, so remember, this is dynamic, where static NAT entries, those entries, when placed into the NAT translation table, those entries are there permanently. Let's see if this has had time to time out. No, so this is still going to be there. Now, this is also a key question, and let's continue to drive on here because the question is going to come up. Well, how long is that NAT translation going to be there? So we're going to pull up the web browser on PC1. Let's type in 209.165.201.5. And all right, we've been able to get to the web server. Let's quickly transition to the router and do a show IP NAT translations. And what do we see now? Same thing coming from a different inside global address, which means it's a different inside local address. This is 10.1. That's PC1. And again, the outside local and global, right? The destination source port is going to be 80 because we're looking at HTTP. And the entry is pretty much the same, with the exception that you've got the second available assignable IP in that subnet range we identified in our pool command is now being used. So remember, when we looked at the pool, right, or the pool command, and we used that /30 when I said 209.165. Where's that? 76.196/30. That meant that we had two usable IPs, 197 and 198. So 199, that is my broadcast address if this is being treated as a /30. And you'll notice the first address we ended up with here was 97. The second address is 98. So what is that going to mean when the third device tries to connect? Because do we have, at this point, are there any additional usable IP addresses given that subnet range that can be used? The answer to that question is no. We have already used up the two usable IPs in our two translations here. And so, as you can see, the exercise is kind of really walking us down this path. Whoops, sorry, I didn't want to shrink that. And we'll go to the desktop in the web browser, and let's go ahead and type in the address. And so now the third host is going to try to connect. So 209.165.201.5, and I hit enter, and I'm also clicking go, right? And are we getting hello server 1, welcome to server 1, right? Are we seeing, and it's gone here, so let's say 209.165.201.5. Are we seeing server 1, welcome to server 1 for PC2? We are not. In fact, we're getting request timeout. So if I come back over here, if I type show IP NAT translations, you can see that it shows the, it's just simply showing a different translation on a different port number here, but it's for the same inside local IP, right? And when I initially saw this, I was hoping that Packet Tracer didn't drop in the connection from 10. What I would anticipate PC2 is going to be 10.2. Let's check his IP out. Yeah, so he's 10.2, right? And he cannot access that web page because the two addresses that fall inside that range have already been used. And so this can often become sort of a point of confusion on a lot of the exercises, because when they show you the pool command, in some cases they give you the range, but they don't show you what the size of the actual subnet is between the router, your customer router, and the internet. So here we see it's a /27, so we know we've got 30 usable IPs. 2 are being used for the routers here, so it leaves us with 28. In the pool command, right, and let's do a show run. In that pool command, when I say IP NAT pool R2 pool 209.165.76.196, and then I declare that this is a /30, what I am saying is, and what iOS checks, is it checks to see, is this a valid subnet ID that would fall within the /30, and is that a valid address that would fall within that /30? If these entries were incorrect, right, if I went larger than that, so let's say I type in IP NAT pool, we'll say R3 underscore pool, and I'm going to say 209.165, where are we at? We'll go to the next address up here, 165.76.200, right? And then I'm going to say the next address I'm going to use would be 209.165.76. Now, if this was a /30, it would be 200, 201, 202, and 203. But what if I put down 205? Net mask of /30, 255, 255, 252. Now, what do we see here? And I apologize, we've got this in the way. And let me go ahead and let me clear this out here, make it a little less crowded. So what happens? We receive an error message here telling us R3 pool mask is too small. Should be at least 255, 255, 255, 248. Start and end addresses are on different subnets. So that's that step I was talking about that iOS is going to do when you enter this command in. It's going to check to see, is the starting IP and the ending IP, are those IP addresses, would they fall within the subnet that's being implied, right? So here they clearly do not, because if it's a /30, my broadcast would be 203. 204 and 205, those are part of a completely different subnet. And iOS does the work for you here and lets you know that it's wrong. So back to what can be a little confusing is sometimes you will see entries for the pool where it will show 209.165, and I'll just say 200.224, and then it'll run it all the way up to, let's say, 209.165.200. What would it be? Block size is 16, so 240. We'll say up to 240. And then it'll show you a subnet mask of 255, 255, 255, and what is that going to be? It's 2 to the 4, so 28. So that's going to be 224, 240. Is that correct? Let me make sure I got that right. 128, 192, 224, 240. Yep. All right. So, and you'll see this listed, right? And in the drawing, they'll show you router 1, and they'll show the serial connection out here to the internet, right? But they don't show you what the subnet size is of this entire area here, okay? So just remember that when you declare that this is a .240, which is going to be a /28, iOS is going to do the math to make sure that, and you know what, I just made a mistake right here, I apologize. Or no, we're good. 224 to 240. I'm trying to remember, I've seen it in the book before. I can't remember if it was 239 actually or 240. But remember that iOS is going to do the math, and these would not be in the same subnet. It had to be 239 that I saw. So in fact, let me scratch that out there. Sorry about that. So we're going to say 239 here, right? If that's the range, it's going to check to see, are these addresses in the range? So the question becomes, if this was a /28, would you declare your pool to be every single IP that would be in here, right? Like we've just done. You've got your network ID, you've got your broadcast address. Would you do that? And chances are you wouldn't, right? Because one of those pool IPs is going to be assigned out here on the internet side. Another one of those pool IPs is going to be assigned to this interface right here. So typically that's where you would take a look and say, oh, it's a /28. I just need a couple of these IPs. Then you would use either a /29 for your pool size or a /30 for your pool size. Keeping in mind that both cases, that network ID that you specify is not going to be usable, and if it's the broadcast address that you specify in the range, that's not going to be usable. So one last quick look here is, what if you put down for the range the actual IPs to be used, and not so much the starting IP and the ending IP that are basically your network ID and your broadcast address. So I could say something like, IP NAT pool R2 pool, and have my starting address be, let's say 100.1.1.1, and then the ending address being 100.1.1.2. And if I were to say that this is and put the net mask on here of a 255.255.255.252, I'm saying this is a /30, right? Again, iOS is going to do the math and say, well, if this is a /30, that is certainly not the network ID, because remember, the network ID is always an even number. And this is definitely not the broadcast address, because the broadcast address is always an odd number. So iOS looks at my statement and says, okay, if that's the starting IP and that is the ending IP and it's a /30, that implies that the network ID is going to be 10.1.1.0, and I'll just put net ID here, and my broadcast address would be 100.1.1.3. So you can put the entire range of addresses, right, including the net ID and the broadcast address, like we've done here in this exercise. We did that, right? Or you could put in the actual range of usable IPs, and iOS is going to do the math for you and figure out, is this even legitimate? Is it possible? And then if it is, it implies that this is the network ID, and that this is the broadcast address, and that these are the two addresses that would be assigned in a dynamic NAT scenario. Okay? And again, this could be part of a much larger subnet, right? This is just another way to do it. So remember, you could see 100.1.1.0 in the pool statement, 100.1.1.3. Like very similar to what we just did here, right? Because we started at 196 with our pool statement and ended at 199. So you can see it like that. But don't be surprised if you see the actual addresses listed, right? Because iOS will do the math and it will come up with the .0 and the .3. So what I'm trying to say here is, how could this have been written? We could have said IP NAT pool R2_pool 209.165.76.197 over to 209.165.76.198. So the 197 and 198, those are my two usable addresses, right? And iOS will figure out on its own that if this is a /30, right, and these are the two usables, that cannot be the network ID. It can't. It's an odd number. It has to be an even number. And if this is in there as well, then it's implied that the network ID is going to be that 196 address, right? So hopefully you see that you could have done this both ways. Now, obviously, Packet Tracer may be looking for our statement with the specific pool setting that we had, and it's not up here on the screen. where we put in all 4 addresses, right? But this statement here can be read, it can be a little misleading because it's saying configure R2 with a NAT pool that uses all 4 addresses in the 209.165. But again, you can't use all 4 of these addresses, right? You can only use the 2 usable IPs that you've identified based off the subnet mask that we've declared. So let's take a look and see what would happen. And let's see, 1, if Packet Tracer gives us the points, and 2, if it works. So here's what I'm going to do. I'm going to go ahead and say no, and we're going to pull out this bogus NAT statement here. So copy, paste, so let's get rid of that. And I'm then going to pull out our legitimate NAT statement. Copy and paste. And so it's probably going to take away the points, but that's okay because we've already we finished the exercise. But this is something we definitely pool is in use, cannot destroy. Okay, so we're going to say do clear IP NAT translations. Incomplete command. Let me do clear IP NAT translate. Oh, asterisk. Sorry about that. So I'm going to clear it. So we'll say do show IP. All right, we don't need the do. Show IP NAT translations. So there are none. Let's see if it's going to let me pull it out of here now. Pool in use cannot destroy, and it might be because we've got it tied to, let's say, no IPNAT sourceless 1. Let's get rid of this ACL, see if that, I believe this is it here. And then let's pull that command back up. There we go. All right, so we've pulled the IPNAT inside sourceless 1 pool, R2 pool, the statement associating the ACL to the pool, and we've pulled out the pool statement completely. Because I want to redo the pool statement, and let's see R2 underscore pool, because we already saw that there are only 2 addresses that can be used here. The third host was unable to connect through. So I'm going to say 209.165.76.196, oh, sorry, 197 to 209.165.76.198, right? So just like the example we talked about over here, where you could actually identify the IPs, the usable IPs, we're doing that same thing here. Netmask 255, 255, 255, 252. Now, you'll notice that iOS did not kick up any kind of an error message here, right? That is a valid command. However, notice what happened over here. We did not, it didn't give us any points. Let me add back in the IPNAT inside source list 1 pool R2 underscore pool command. And let's see if that was the final check it was looking for. My guess is it is not, right? However, we've got the NAT command in there. So now let's go ahead and do show IP NAT translation. You can see we've got no translations going on. Let's check again here. So let's jump back on this web browser, type in 209.165, and I forgot the IP, 201.5. Is this going to work? And take a look at that. It does, right? So now let's take it one step further. Let's take a look at PC1. Let's type go, right? PC1 or stop here. I guess we'll pull it back up. Start from scratch. 209.165.201.5. Yep, that works. Let's quickly take a look here. Do show IPNAT translations. And the reason there's so many entries is when I was hitting go, go, go before I closed it and reopened it. And you can clearly see on which host I was doing that. 10.1, which is PC 1. So now the final check. Let's take a look at PC 2. 209.165.201.5. Nope, it doesn't work. So again, we didn't get the points, but it's critical to understand that when you declare the pool statement, your starting and ending IP addresses You can use the network ID and the broadcast address if you'd like to. We did that the first time. It worked great. However, you don't have to set it up like that. You can simply specify this first usable IP to this last usable IP inclusive that would be within that subnet range, right? And iOS is going to take that command. It figures out that those are legitimate based on the subnet mask. They're legitimate addresses that would be within that range. And so again, this is one of the things that can become very, very confusing from looking at the text in some cases where they show you the network ID is the first pool address, and then typically the broadcast address is the last pool address, and don't give you the overall size of the subnet that's being used between your customer router and the internet. And so this is also another way where you can pick out the range exactly of the exact addresses you would like to, the usable addresses that you would like to use. Okay. And NAT is definitely one of the more challenging topics without a doubt. So that wraps up Packet Tracer Activity 5.2.2.5, and hopefully this has given you a much better understanding of NAT and specifically why sometimes you'll see the network ID and the broadcast ID included in that range, but they're not usable, right? So again, if I needed more than 2 addresses, I wouldn't use a /30, I'd use a /29. But again, if I use a /29, keep in mind that if I start the IP address range with the subnet ID for that /29 and end it with the broadcast address for that /29, those 2 addresses will not be used to map inside local addresses to inside global addresses. They are already spoken for because they would be the network ID and the broadcast address. All right, I hope that clarifies maybe any confusion that you might have had. I know a number of students have asked questions about that, based off of how that pool statement gets configured, why you see the network ID and broadcast address sometimes, and then why other times, why does it have actual IPs in there? All right, thank you for watching, and I will see you on Saturday.